In the third section of this chapter, we will be talking about industrial cracking. The learning objectives of this section are to describe what cracking is, to explain the economic reasons for cracking, to describe the conditions and the products of thermal cracking, and finally to describe the conditions and the products of catalytic cracking. In this tutorial, we will be working on the first two objectives. So, what is cracking and why do we use it? In the previous section, we talked about fractional distillation. The naphtha fraction from the fractional distillation of crude oil is in a huge demand for petrol and by the chemical industry, whereas the longer chain fractions, which are collected at the bottom of the tower, are not as useful and therefore they are of lower value economically. Most crude oil, as we have seen before, has more of the longer chain fractions than is wanted and not enough of the naphtha fraction. So the problem is that crude oil has more of the longer chain fractions which are not used and less of the naphtha fraction which is widely used. So the shorter chain products are economically more valuable than the longer chain material. So we must balance between the demand for the shorter chain hydrocarbons and the supply of the longer chain fractions. So to meet the demand for the shorter chain hydrocarbons, many of the longer chain fractions will be broken into shorter ones. So this is cracking. It is breaking down longer chains of alkanes into shorter ones. And this has two useful results. The first one is that shorter and more useful chains will be produced, especially petrol, and some of the products will be alkenes, and alkenes are more reactive than alkanes. Pay attention that petrol is a mixture of mainly alkanes containing between 4 and 12 carbon atoms, so longer chains of alkanes will be broken into shorter chains containing between 4 and 12 carbon atoms. Alkenes are used as chemical feedstock, which means that they supply industries with the starting materials to make different products. And they are converted into a huge range of other compounds, including polymers and a variety of products, from paints to drugs. Ethene or ethylene is considered to be the most important alkene, and it is the starting material for polyethylene and a wide range of other everyday materials. So it's really important to produce alkenes because they are used as chemical feedstock. Unlike alkanes are very unreactive and harsh conditions are required to break them down. In the upcoming tutorials, we will talk about thermal cracking and catalytic cracking.